So this is from chapter or unit 3. So for this question, you're going to have to draw a triangle, and it says EFG is the triangle, E is 30, F is 60, G is 90. So I'm going to draw myself a right triangle. And I'm going to label it EFG. Actually, I'm going to draw in the 30, 60, 90 first, and then I'll label the appropriate angles. Okay, so we'll say this is 30 degrees, this is 60 degrees, and I've got my 90-degree right angle at the bottom. So E is 30, F is 60, G is 90. Which of the following statements about EFG are true? And you're supposed to check all that apply. Okay, so for this problem, we have to think back to like our special right triangles. We don't know anything about the sides specifically, but we know that the sides are proportional. So what we learned is that like this side, FG, the side beside the 60-degree angle, we call that the shorter leg. We're just going to label it S. And then to find the other two sides, we take the shorter leg, which is S, and multiply it by, this one is S radical 3, and then this one is 2S, okay? So what that is saying, like for this one, what that is saying is that the hypotenuse, FE, is equal to 2 times the length of the shorter side, FG, okay? And then we also have this one. The longer leg, so GE, is equal to radical 3 times the shorter leg, FG. And then we'll have to see if any of the other ones are accurate. So we want to look for those two. And of course, they're the opposite. So instead of FE and GE, it's EF and EG. So EF equals 2 times FG. We're looking for that one. That's right here. EF equals 2 times FG. Okay, I got that. And then EG equals radical 3 times FG. So EG equals radical 3 times FG. That's this one. So I have that one. Now we can also go backwards. So we could say, so like we have to kind of check the other ones. The first one says EF, that would be this side, the hypotenuse, equals radical 3 times FG. That is not correct. So that would be times the shorter leg. We already have one for that. Okay. D says EG equals radical 3 over 2 times EF. So we kind of have to figure that out if that would be correct. So if I kind of made an equation out of this, we have EG is S radical 3 equals radical 3 over 2 times EF would be 2S. I kind of want to see if this is true, if this equation is balanced, okay? So what I see automatically, just on the right-hand side of this equation, this is like over 1 technically, so this 2 on the bottom and this 2 on the top cancels. So then I have S radical 3 equals radical 3 and then times S. So those are the same. So technically, even though this is a weird one, that does work, okay? I'm going to switch to a different color. Okay, so this one I'm going to do in blue for E. So this one says FG, so I'm going to plug in what I have for FG. That's this side right here is S. Sorry. So S equals, and then radical 3 over 2 times EF. EF is 2S. So again, we want to put this over 1. I'm going to cancel out the 2, see if it simplifies. So we would have S equals radical 3 times S. Those are not the same, so no, this one does not work. Okay. And then finally, in purple here, I want to try the last one. So EG, which is down here, S radical 3. Sorry, it keeps moving. Equals 2 times FG. That is S on the side. So S radical 3 equals 2S. No, those are not the same either, okay? So you just kind of like use what you know to figure out the ones that are obviously right based on our proportions, and then we just kind of have to substitute what those little formulas that we have. So like anywhere there's an FE, we would plug in FE into that, okay? and just eliminate what you can.